Everyone, we're going to look at number 4 in section 3.3, where we're going to use the quotient rule to calculate the derivative for this function at t equal 2. Notice the independent variable here is t. And when you look at the place to enter in your answer, they've got this symbol, so make sure you understand what this means. This is really evaluating what is dg dt. That's the Leibniz notation for the derivative of g with respect to t. This vertical bar means evaluated at t equal 2. This is basically the same thing as saying g prime of 2. Okay, so we have the prime notation, we have the Leibniz notation. So make sure you understand the dg over dt is the same as g prime of t, which is also the same as the derivative with respect to t. That's how we write that, d over dt of gt. So these are kind of mixing these ideas or these notations, and you see these quite a bit. So make sure you understand both notations and that what they represent. Now, the quotient rule I've simplified or read out briefly here. If you have a function u divided by v, then the derivative of that quotient is the derivative of u, which is the numerator or top function, times v, the denominator or bottom function, minus u, the top function, times the derivative of the bottom function v, all over the bottom function squared. So this is a nice shortcut rule, but you do need to make sure you remember this one and how this subtraction works, because if you get this out of order, you obviously get -1 times the derivative. Okay, so let's find the derivative. The top function, my u, if you will, is t cubed plus 2. The bottom function v is the t cubed minus 2. So the derivative of g with respect to t is the derivative of the top function times the bottom function. All right, that's u prime times v, minus the top function, u, times the bottom function, v, derivative, right, v prime, all over the bottom function, all quantity squared. Okay, so let's do the calculus part in terms of the derivative here. T cubed plus 2, what's the derivative? Derivative of t cubed by the power rule is 3t squared. Derivative of 2, a constant, is 0. So that's just 3t squared. By the same argument, the derivative of t cubed minus 2 is also 3t squared. So here's our derivative. Of course, it would be good to simplify this, and let's do that. Distribute the 3t squared through here. All right, so when I do this to the t squared times t cubed, I'm adding the exponents to get t to the 5th. 3t squared times 2 is 6t squared, and it's minus here. Be careful with the minus sign here. I've got minus t cubed times 3t squared is minus 3t to the 5th, and minus 2 times 3t squared is minus 6t squared. The bottom, I'm not going to FOIL that out. I'm going to leave that factored, because what we would want to do is see if we can factor anything up here. But we first need to simplify up here, and it simplifies very nicely because the 3t to the 5th minus 3t to the 5th is 0, and you just have this minus this, which is -12t squared, right? -6t minus 6, -6t squared minus 6t squared, -12t squared. And there's as simplified as we can get. This is completely factored in the numerator and denominator, and so this would be the derivative. Now, of course, what we're asked to find is the derivative evaluated right at t equal 2, which is this expression. So that just means we need to plug t equal 2 into this derivative, and everywhere I see a t, I replace it with 2, and I evaluate that. Hopefully that makes sense, and simplify down to -4/3. So that's how we work this one out. I hope this is helpful.